Okay, welcome back. This is the next in the series of videos for the Reigate College Maths post-Easter work. This video focuses on geometric series. So, like before, a series is when we take a sequence and add it together. Okay, so these are both geometric, but this is a geometric sequence, and this one is a geometric series. Now, the formula for the sum, for the value that this adds up to, like arithmetic series, you're given, but you need to know how to prove it. So you are given this formula. That is the formula for the sum of the first n terms of a geometric series. But you need to prove it. The proof is a little bit more uncomfortable than that of the arithmetic series. So we're not going to go through kind of holistically trying to work it out. We're just going to go through it. So we know that the thing we're trying to find is the first term plus the second term plus the third term up to and including the nth term. Now this is where, if we look at where we're trying to get to, this can help inform what we need to do. If we look at what we're trying to get to, we have an r to the n. Currently, we have an n minus 1. So, how do we get to n, or with a power of n, from n minus 1? We times the whole thing by r. Well, we've got a bunch of extra terms. If we look, though, these are the same. These are the same, and so on. So if we do one, take away the other, then these terms here are going to cancel. So we get that Sn minus Rsn is a minus ar to the n, because we're subtracting it. We're trying to find Sn, so let's take that out of a bracket. And let's factorise out an a. Hopefully you can see we're nearly there. And we get the formula we needed by dividing through by 1 minus r. This proof is a lot shorter, but it is a little more confusing, potentially, to remember. what we're going to do now is we'll have a look at the 3 questions on the page of the workbook, which again you can find on Moodle. So, question 1. Given the series 2 plus 6 plus 18 plus 54, find the 7th term. So, we know that the 7th term is AR to the 6. So, we need to work out A and R. Clearly A is 2. Now, hopefully you can see that R is 3, but let's prove it. The common ratio is always the second term divided by the first term. Or, more generally, it's one term divided by the term before it. And that proves that the common ratio is 3. So the 7th term is 2 times 3 to the 6, which we just do on the calculator. 2 times 3 to the power of 6. And we get 1,458. Again, much like with the example we saw before, these numbers are going to be much, much bigger than arithmetic series. Next question, we want the sum of the first 7 terms. So we are looking to find S7. So we know that this is going to be A times 1 minus R to the 7, being careful with the formula, over 1 minus R. So again, A is 2, 1 minus 3 to the 7, over 1 minus 3. Type it in the calculator, and we get our answer. $2,186. So not too tricky. So let's have a look at question 2. So this is more harking back to the geometric sequence stuff we were doing before, but it's a good example nevertheless. So the sum of the first 2 terms of a geometric series is 28. So although it says sum, let's not think about Sn and that formula. Because the sum of the first 2 terms is u1 plus u2. That's 28. And we also know the sum of the 4th and 5th is 756. Because we're looking at just individual terms, this is not the sum of the first 4 plus the sum of the first 5. This is just the 4th plus the 5th. We don't use the summation notation, or the S notation. All this tells us, so let's call this 1. All this tells us is the first term plus the second term is 28. So we know that A times 1 plus R is 28. We'll call that equation 3. Equation 2 tells us that AR cubed plus AR to the 4 is 756. So A times R cubed plus R to the 4 is 756. Let's call this equation 4. Now, like when we were doing our proof, we can do simultaneous equations. So if we do this one, so equation 4 over equation 3, we get A times 1 plus R over A times R cubed plus R to the 4. And that's 28. Oops, got those the wrong way. 3 over 4, doesn't matter. Over 756. Now the A's are going to cancel, but we can also do make other things cancel. If we look and see the denominator here, we can take R cubed outside of our bracket. (28 over 756) simplifies to 1 over 27. So we get 1 over R cubed is 1 over 27. Now obviously if I'd done this fraction the other way up, it would have been a little easier, but this is proving that it works regardless. So R cubed is 27, R is 3. Now we know from equation 1 that A plus 3A is 28, 4A is 28, and so A is 7. The last one, question 3, is very similar to a question we did before, with the terms which exceeded a million. We're now looking for when the sum exceeds 1 million. So here, in the last video, we did the first term to exceed a million, because this was a sequence and we wanted just the term. What we're looking at this time is the least number of terms for the sum to exceed a million. This is exactly the same question, just using a different formula. So we know from before that A is 3, from the previous example we did, and the common ratio is 2. Now this is a bit of an annoyance. Hopefully you can see that this is a minus number on the bottom, because 1 minus 2 is minus 1. But this is also minus number, because n just gets bigger, so this becomes minus. So in fact, let's deal with that now. So 1 minus 2 is minus 1, but this is the same as saying 3 times 2 to the n minus 1 is greater than 10 to the 6. So we get 2 to the n minus 1 is greater than 10 to the 6 over 3. 2 to the n is greater than 10 to the 6 over 3 plus 1. Now, like before, we should take logs of both sides. And remember that when we take logs of both sides, we are only allowed to write one log in front of each side. So it's just that. Don't worry that this is really unpleasant. We're just going to stick it in our calculator and deal with it that way. Again, log 2 is definitely positive. Stick that all in your calculator and we get, so log to the 1 million over 3 plus 1 over log 2 is 18.34. So n has got to be greater than or equal to 19. So the least number of terms required for the sum to be greater than 1 million is 19. Question 4 is the proof that we've already looked at. So now to practice. Exercise 3D, page 72. Question 1, 2, 5, 7, 9 to 11. Okay, and when you've done that, come back and watch the next video about what happens when we add together a geometric series that converges.